In this video, we're going to take a look at some additional examples on how to find the probability of a particular event, specifically using the normal curve or the normal distribution. So our objective is to calculate the probability using normal distribution, and to do that, we're going to use the website that is referenced here on the slide that you can go ahead and open up, and I'll be referring to throughout the video. So let's jump right in. The first example says, according to the American College Test, results of the 2004 ACT testing found that students had a mean reading score of 21.3 with a standard deviation of 6. Assume that the scores are normally distributed. First of all, as you begin reading through these problems and thinking about it, there's really three things you have to know as you think about how to go about working the problem. First off, you have to know that you have a normal distribution, which it clearly states in the problem. Secondly, you have to know the mean of that normal distribution, which is given in the problem. And then third, you have to also know the standard deviation, which is also given in the problem. Now, we can write this in a shorthand way so that we have the information as we go throughout the problem. To write this information in a shorthand way, we would say X is approximately normal. Then we put a parenthesis, and then we put the mean, which is 21.3, and then we put the standard deviation, which is 6.0. And then they ask us a question. It says, find the probability. Okay, so look at the phrasing. This kind of tells you which website to use and which process to follow. It says, find the probability that a randomly selected student has a reading score less than 20. Now, here again, that particular problem can be written in symbols. It would be the probability that our X value is less than 20. Now, I want us to look at a visual. What would this look like visually? So we know we have a normal distribution. So you're going to have the horizontal axis, the bell-shaped curve. We label the mean in the middle, which is given to us as 21.3. And then we got to think about where would values less than 20 be? Well, 20 is less than 21.3. So somewhere to the left of the mean is going to be 20, and we want to know about the values less than that. And remember, in the normal distribution, that the area under the curve corresponds to the probability. So I need to find this area. And since we're not doing calculus, we're going to rely on the technology to do that. So I'm going to go out to the website now. And you have to enter the mean, which was given to us in the problem as 21.3. You have to enter the standard deviation, which was 6.0. And then we wanted to be less than. Less than implies we're below. So I'm going to check the box next to below. And then I give it the value. I wanted to be less than or below 20. And I hit enter. And when I hit enter, it gives me the value in the results box at the bottom of the screen. So my value is 0.4142. So I'm going to go back and I'll write that on the thing. So the probability that I am less than 20 is 0.4142. Now that's a decimal. Okay, if you want it as a percentage, we would multiply that decimal by 100, so it would be 41.42% chance that a randomly selected student scored less than 20 on the reading portion of the ACT. Okay, don't overthink it. All the information is given to you in the problem, and then you plug the information into the website. And you'll notice this picture that I drew here, they also give that to you on the website, so it looks similar. They have numbered the horizontal number line, okay, which I don't do, but you get the sense of that it does look very similar to the one that I hand drew. All right, number 2, same scenario, ACT results from 2004. We had a mean reading score. Again, notice they tell you that it is normally distributed, which we have to know. They tell us that the mean reading score is 21.3 and that the standard deviation, again, is 6. You have to know those 3 things. Okay, then it asks us, what's the probability that a randomly selected student scores between 18 and 24? Okay, so again, in symbols, we would have X is approximately normal with a mean of 21.3, standard deviation of 6. Expressing the problem in symbols, I would have the probability that we're between, we say it's 18 is less than X is less than 24. That's how you express between, and that word between is going to be important in just a minute when we go out to the website. So looking or thinking about our curve, you would have your horizontal axis, your bell-shaped curve, the mean in the middle, which is 21.3. Then you have your 2 points of reference. You want to be 18, which would be to the left of the mean, and then 24, which is to the right of the mean, and we want to be between those values. So you're looking for this red shaded region. Again, we're not doing calculus, so we're going to go out to the website and plug in the information. Okay, so I'm going to go back to the website. My mean is still 21.3. My standard deviation is still 6. I'm doing between. That was the phrase in the problem, and we're using 18 and 24. We hit enter. Again, notice you get the visual. It looks similar to the one that I drew for you. We get 0.3825 in our results box. Okay, so the probability written in decimal form is 0.3825, and again, that's the decimal. If you need it as a percentage, you multiply by 100. So it would be 38.25% score between 18 and 24 on the reading ACT. All right, example number 3. Again, we have the same scenario. They tell us that the ACT reading scores are normally distributed, that our mean reading score is 21.3, and we have a standard deviation of 6. We want to find the probability that a randomly selected student has a reading score greater than 30. Okay, so again, if you write it in the symbols, we would have X is approximately normal with a mean of 21.3 and a standard deviation of 6. Writing the question in symbols, we'd have the probability that X is greater than 30. And another way to express greater than, which we're going to need when we get to the website, is above. So they use the word above for greater than. They use below for less than. Okay, so if we draw our picture, let's see. I'll have my horizontal axis, bell-shaped curve, the mean in the middle, which we're told is 21.3. In this case, my point of reference is 30. 30 is greater than 21.3, which is the mean. So we're going to be somewhere to the right and to be greater than that. So we're looking for this shaded region out here on the end, or in what we call the tail. Okay, so I'm going to go out to the website, put in my information. Again, the mean is 21.3. Standard deviation is 6. This time I want to be above a specific number, and the number I want is 30. Hit enter. And in our results box, we get 0.0735. And again, the picture I drew looks similar to what's on the screen at the top. Okay, so we go back and write down our answer. So the probability that x is greater than 30 is 0.0735 in decimal form. Okay, and if you want to change that to a percentage, you multiply by 100. So it'll be 7.35% score above or greater than 30 on the reading portion of the ACT. Okay, example 4. This one changes. Women's heights are normally distributed with a mean of 63.6 inches and standard deviation of 2.5 inches. The U.S. Army requires women's heights to be between 58 and 80 inches. Find the percentage of women meeting that height requirement. Are many women being denied the opportunity to join the Army because they are too short? Okay, so again, look at it. It tells us in the first sentence that women's heights are normally distributed. It also tells us that the mean of women's heights is 63.6 inches, and the standard deviation is 2.5 inches. Okay, so we know the three things that we have to know. We know that it's normal, we know the mean, and we know the standard deviation. In shorthand, we would have x is approximately normal with a mean of 63.6 and a standard deviation of 2.5. It then goes on to explain that the Army requires women's heights to be between 58 inches and 80 inches, and it wants to find the percentage or the probability of women that meet that height requirement. So we're really looking for the probability that they're between 58 and 80 inches. That's really what they're asking. Now, you may have to kind of read a little bit in between the lines, but we want to do between 58 and 80 inches. Okay, so if I draw my picture, I have my horizontal number line, my bell-shaped normal distribution. The mean is given as 63.6. 58 would be to the left because it's smaller than the mean. And 80 would be to the right because it's larger than the mean. And we're looking for this red shaded region. So now we're ready to calculate. We're going out to the website. Okay, our mean this time is 63.6. You enter the mean. We enter the standard deviation, which was 2.5, and we want to be between 58 and 80. Okay, so you enter all the information that comes directly from the problem. We enter, and again, our results give us the value in the results box. We get 0.9875. Okay, so going back, so the probability that a woman is between 58 and 80 inches is 0.9875, or as a percentage, since they asked for a percentage, is 98.75% of women would qualify to be in the Army. So then we answer this last question, they ask us a little sub question here, and it says, are many women, are many women Are many women being denied the opportunity to join the Army because they're too tall or too short? Well, the Army will accept 98.75% of women. So if we think about what percentage of women would not qualify, we know that our total percentage is 100. So I have 100. Oh, goodness gracious. We know we have a total of 100%. Okay, so 100% minus the 98.75% that are eligible leaves us with 1.25%. So only 1.25% are rejected or not eligible. So I would say no, not many women are being denied the opportunity to join the Army because they're too tall or too short. I mean, it's only 1.25%. All right, example number 5. This one deals with monthly mortgage payments. It says the average monthly mortgage payment, including principal and interest, is $982 in the United States, with a standard deviation of approximately $180. Assuming the monthly mortgage payments are normally distributed, find the probability that a randomly selected monthly payment is more than $1,000. Okay, so here again, if we think through it, okay, first of all, they tell us to assume that the payments are normally distributed. They tell us that the average is 982 and the standard deviation is approximately 180%. Okay, so writing that in our shorthand notation, we would have X is approximately normal with a mean of 982 and a standard deviation of 180. And then it asks us to find the probability that a payment is more than 1,000. So the probability that X is more than 1,000 or is greater than or is above 1,000. Okay, draw your picture. Horizontal number line, bell-shaped distribution. The mean is in the middle, which we're told is 982. $1,000 would be more than that, so we're going to be somewhere to the right with our $1,000, and we want to be more than that. Okay, so I'm going out to my website. Got to enter the information. My mean is stated as 982. My standard deviation is given as 180. In this case, I want to be more than, greater than, or above 1,000. So I choose the option above, and I get 0.4602. Okay, so the probability that I am more than 1,000 is 0.4602. There's about a 46% chance that my monthly mortgage payment would be more than $1,000. Okay, next. Same scenario, monthly mortgage payments. We're told to assume they're normally distributed. We're told that the average is $982. The standard deviation is approximately $180. And this time we want to determine if the monthly payment is more than $1,475. Okay, so making notes of our information, X is approximately normal with a mean of 982, standard deviation of 180. Again, we want to find the probability that our payment is more than, greater than, above $1,475. So drawing my picture, horizontal number line, bell-shaped distribution, mean in the middle, which is 982. 1475 or 1475 would be above that. So here's 1475, and we're above. Going out to our website, our mean is 982, standard deviation is 180. Now I want to be above 1,475. So I change the number, hit enter, and it gives me a value of 0.0031. So the probability that my mortgage payment is more than 1,475 is pretty small. It's 0.0031, or if you write that as a percentage, it'd be 0.31%. So there's less than a 1% chance that your mortgage payment is going to be more than 1,475. One more. Still dealing with the mortgage payments. Again, they tell us in the story it is normally distributed. They tell us that the average is $982. They tell us that the standard deviation, sorry, I got a little crooked there, is 180. And this time we want to know the payment is between $800 and $1,150. So we know that X is approximately normal with a mean of 982, standard deviation of 180. We're looking for the probability that we're between 800 and 1150. Drawing our picture, horizontal number line, bell-shaped curve, mean in the middle of 982, and we want to be between 800, which would be below the mean, and 1150, which is above the mean. So we want to be between those two values. Now I'm ready to enter it into the website. Mean is 982. Standard deviation is 180. We're doing between, and we're using a value of 800 and 1150 as stated in the problem. Again, notice the visual at the top looks very similar to what I drew. We get 0.6687. So the probability that our mortgage payment's between 800 and 1150 is 0.66. Forgot what I said. Was it 57? 87. 56687. Or we have about a 66.87% chance that our mortgage payment is going to be between $800 and $1,150. So I hope these examples you'll find helpful and will help you to see how to work through the problems on finding the probability or finding the percentage of a particular event using the normal distribution.